Hi, this is Julie Harland, and I'm your math gal. Please visit my website at yourmathgal.com where you could search for any of my videos organized by topic. In this video, I'm going to show you a proof of the Pythagorean theorem. If you look online, you could probably find about 100 different proofs of the Pythagorean theorem, so this will just be one way to show that the Pythagorean theorem is true. So we're going to start out with what the Pythagorean theorem is. In a right triangle, the area of the square of the hypotenuse equals the sum of the areas of the other two sides. And those are also called legs, the other two sides. So I have a picture of a right triangle here, and we've got the hypotenuse is C. It's the longest side, so we have a right angle between the other two sides, and I'm going to call those sides A and B. Those are often referred to as the legs. Now it's common if you have a little a for the side of a triangle that if you look at the angle opposite, we can use the capital letter A. All right, so there's a correspondence there, so I could call this capital letter B. And instead of putting C here, I'm just drawing the little right angle. And what you know is the sum of the measures of the three angles in a triangle adds up to 180. So we've got a right angle of 90. These other two angles add up to 90 degrees. So I'm just going to write that fact right here that A plus B, those add up to 90 degrees. Those are two angles, for instance. All right, now, what does this mean? The area of the square of the hypotenuse. So what that means is if you took the hypotenuse and made a square out of it, so you can go up here and make a square. I'm just sketching it, of course. A square means all the sides are the same and they're all at right angles, right? So these are 4 right angles. So that's the area. I'm sorry, that's the square on the hypotenuse, and the area of that I'm going to put in the middle would be c squared. Okay, that would be the area of that square, right? You multiply side by side, or you just square a side. That's the whole idea. Now what it's saying is that area is going to be the same as the sum of the areas of the other two sides. So we do the same thing. If I take the square on this side, it looks like this. Again, all right angles. I'm just going to write one right angle. I'm going to say all these are length A. Then the area of this square would be A squared. And we would do the same thing for this other side. Again, making a square on the other side. And we would say the area of this would then be b squared, right? The area of this square would be b squared. Now what it's saying is, if I take the area of this square and the area of this square, the a squared plus b squared, that's the same thing as the area of that squared. So visually, it actually means that, let's see, I need to get the right color here. So if I were to take this area, right, if I painted that much, and I take this area over here, those two pieces together are the same as the area of this big one right here. Okay? The big square. So it's not obvious by looking at it that that would be the same area. Some people, when they think about the Pythagorean theorem, don't even think about area, but it really has to do with the area of these squares here. And the areas of the first two are a squared and b squared. So the Pythagorean theorem, a lot of people just remember this part, that a squared plus b squared equals c squared, right? But that's referring to the area. The a squared is referring to the area of the square of this leg. B squared is referring to the area of the square of this leg, and c squared is referring to the area of the square on the hypotenuse. Now I'm not going to write down a formal proof, but I'm going to show you how this all works. So here's our original triangle, right? what I'm going to do is say, let's extend this side up a little bit, okay, and let's put this leg B over here. So I don't know how big that is, but let's say it's about this big. All right, that's probably just a little bit shorter than that. Okay, so there we are. So this would be B. And then I'm going to extend, at that point I'm going to make a right angle, okay, and I'm going to go out a distance of A. So A is maybe about that far up, okay. So I'm going to put the triangle, the same exact triangle right here. All right, so you see what I did? So I'm just going to label, let's see, if I'm looking exactly the same triangle, here's A, then this angle across from it would be big A, and this is side B, so this is angle B. And the question is, what's this angle right here? Okay, oh, by the way, we also know this is C, right? Because this is the same triangle. If you have side angle side, you have a side and then a right angle on another side, then this actually is exactly the same triangle that you see over here. Might not look exactly because I'm freehand drawing it. But the question is, what's this angle right here going to be? Okay. Well, notice that this was a straight line. So altogether this adds up to 180 degrees. Remember? A plus B added up to 180, I'm sorry, A plus B added up to 90 degrees, and the whole thing adds up to 180. So what's left is 90 degrees right here, right? And 90 degrees means this is actually squared off right here. Now we could do this again. I could go out and extend this, B, etc. And if we do that, we're going to get this picture. So I've extended it out. So what you see are 4 of these little triangles, and you see this big square in the middle. And by the same reasoning, all of these end up being right angles. And if you want, you could also label all the angles in here. Okay, so we've got this. Now let's figure out what the area of this big square is. There's a big square, right? One big square with 5 parts. Okay, what I have are 4 triangles. And in the 4 triangles, each having area. Well, what's the area of each of those triangles? What's the formula for the area of a triangle? It's 1/2 base times height. In this case, that would be 1/2 A times B. So each of those triangles has an area of 1/2 AB. So that's 4 of the parts. It's 4 triangles, each having area 1/2 B, and a square with area what? Okay, what's the area of this square? C times C, so it's C squared. So if you want, you could actually go put all these areas in here. If I want, I could say, oh, that's 1/2 AB. The area of this is 1/2 AB. The area of this is 1/2 AB. The area of this is 1/2 AB, and the area of this is C squared. So I'm circling the area of each of those 5 pieces. So that means the total area, what would it be? I would just add those 5 pieces together. I'd have 1/2 AB, whoops, AB plus 1/2 AB plus 1/2 AB plus 1/2 AB plus C squared. I'm going to run out of space here, so I'm going to make this a little smaller. There we go. Plus the area of the square. So those are the 5 pieces. So the total area of this big old square, well, if we add, we've got 2AB, right? 1/2 plus 1/2 plus 1/2 plus 1/2. Or some people get that by thinking of 4 triangles all having 1/2 AB. Some people write it like this, but no matter which way you write it, when you simplify it, you get 2AB plus c squared. So that's what's important. That is the total area of that square. Now there's another way of thinking about the area of this square. It's one huge square where the side is just one side is a plus b. Notice each side is a plus b. So now we're going to calculate it using the idea of the area of a square is its side times itself. So that would be a plus b times a plus b. So if we look at it again, we see, oh, it's just one big square with side a plus b. So this is like a miniature look at it. Just ignore all the stuff in the center here and just see, well, this is a length of a plus b, so that whole side is a plus b. So it sort of looks like this. This is the miniature scale of it. And so the area would be, of that big square, would be a plus b squared. All right, now how do you calculate a plus b squared? That's a plus b times a plus b. If you don't remember the formula, you could do the FOIL method. Sorry. So we get a squared plus 2ab plus b squared. So we calculated the area of this big square two different ways. By thinking of it as a big square, where just one of the sides is a plus b, and we came up with this for the area, right? And then like peeking up, what did we do before? We came up by adding the 5 pieces with 2ab plus c squared. So those have to be the same. So I've got 2ab plus c squared, and I also have a squared plus 2ab plus b squared. So we set those equal. So set the two areas equal to each other. All right, so one way is thinking of it as a squared plus 2ab plus b squared, right? And the other one, again, is 2ab plus c squared. Right, now you notice that there is a, whoops, 2ab on both sides. Sorry for all my jumping around here. So there's a 2ab on both sides, so I could just subtract 2ab from both sides. And lo and behold, I get that a squared plus b squared equals c squared. And that's exactly what the Pythagorean says should happen, that a squared plus b squared equals c squared. And so there is a proof of the Pythagorean theorem. I'm not writing out all the steps, but I'm showing pictorially how this all works out. The key is to look at this picture here. All right, fitting all the triangles together and noticing in the middle you end up with this big square c squared. You've got the 5 pieces here that make up the area, and you find out what that is, and then you say, but that's the same as just this big square with side a plus b. And then when you do your algebra, you come up with the Pythagorean theorem, back up here, that indeed a squared plus b squared equals c squared. Now, try it on your own. Please visit my website at yourmathgal.com, where you can view all of my videos, which are organized by topic.